Here are some ideas for the big pink slide. The main idea is that the big pink slide is like a conservation of energy thing, right? So you can, they start here, they go down, and the height change is something like 7.2 meters. I think we measured that. It's on the website. But up here you've got MGH, right? At the bottom you've got 1/2 mv squared, okay? And so even though if we don't know the mass of the person, right, if MGH equals 1/2 mv squared, right, you can just cancel the mass, right? And given the height, this is 9.8, right? Okay, you can solve for what the velocity should be. Okay, now even more interesting, right, is that you can figure out what the velocity really is. So at the end, there's lots of videos of the people at the end, so you could figure out what the velocity really is. You could see what it should be, right? And you could compare those two, right? You could compare with 1/2 mv squared of what it should be, right, versus 1/2 mv squared, okay, of what it is, right? You can measure that using video analysis at the bottom, right? And then you could figure out how much energy is lost, right? If you're more ambitious, you could actually figure out what force is actually acting against the person, because I think we know the length of the slide, or we could estimate the length of the slide, right? And then we could figure out that the energy lost, you just set that equal to work as force times distance, right? And then the energy lost is the work, and the distance, you could estimate the length of the slide, and you could figure out the force, right? So that's one idea. I mean, that's a basic thing you can do. The other thing you can do is that really it's not a straight slide, right? So it does this. You can also look at the g-force, the vertical g-force. There's lots of data files like that. There should be some sort of undulation. High g-force would be a high g-force would be when you're accelerating up. A low g-force would be going over the top of these things, right? And you should see these little bumps in there. You could point those out. Other ideas. The other idea, the main idea too, is that you can actually do video analysis of this and do like a velocity versus time graph and analyze these people as they stop by just putting dots on them, right? In video analysis, and you ought to get a velocity curve that looks like that, right? You could put a straight line through it and get the deceleration, right? And then you can say, well, I guess you could say F equals ma. You could figure out the force that's stopping them. You could also use friction, right? The force of friction on this level surface should be mu times m times g, where that's the coefficient of friction. It's something you use to calculate friction. This is 9.8, right? And if that equals ma, their rate of deceleration, again, the mass should cancel. And you ought to be able to figure out with the acceleration what the coefficient of friction is. Huh? There we go. Yeah, those are some ideas.